to you and Mike Carley, who introduced me to this great meetup. So let me start sharing my screen now. And can you guys see it now?
Yep, I see it.
Yep. There we go.
Okay, sounds good. So just a quick introduction about me. I'm Kirti Velankar. I'm a software engineer in the engineering productivity team of StreamSets. And the topic of today is, of course, automation and abstractions, pillars of engineering productivity. So take it as a gift or curse of video conferencing. I cannot see you in person. So if we were in actual in-person conference or meeting, I would have asked you this question, but that's not the point. The point is I wanted to ask you guys how many of you know about StreamSets. So I'm just going to assume some of you know, some of you don't. So I'm just going to do a quick introduction in 2 slides. And in fact, that is going to give us a context for my presentation. Okay. So the first is, what is the challenge that we are trying to tackle with? So in machine learning, or today's world of modern analytics, data is your lifeblood. Data is a critical asset which companies use in many different ways and many complex ways. Maybe they are using it to analyze customer engagement. Maybe they are using it to do the fraud detection, or maybe they're doing it or using it for doing the next big thing. But the real struggle is to move that data from its source to the destination. So in this particular diagram, from left-hand side towards the right, where it gets used for analytics, ML, and whatever the purpose is. And to move that data on time, continuously, and without any data pollution. That is where StreamSets comes to help. And what is the solution they offer? So we offer StreamSets DataOps platform. Ta-da! So as the diagram shows, this is a quick intro. So the blue boxes in the middle are 2 high-performance execution engines, namely Data Collector and Transformer. The top layer is Control Hub, which allows you to design, deploy, and govern these modern data pipelines at scale. And the bottom layer is showing that for us, your data can reside anywhere. It can be on-premise, in the public cloud, or in the hybrid cloud. Great. With that quick intro on, to our company, let's dig into what is engineering productivity. So the first one is, I believe that's a definition from Google. The second one is from some other company, but you get the point that if you search online, different companies have different definitions, different meaning. As StreamSets, we think engineering productivity enables engineering teams to rapidly deliver. So modern infrastructures and systems are complex. The technology in them is fast evolving. No one person can keep up track with those changes and the complexities. And in order for the engineering teams to be successful, they need to have room to focus on what they're building. And this is what, to bring the simplicity to the complexities of this infrastructure and system, is where engineering productivity comes to help. Our team does the tooling and processes to achieve it. So today's agenda is, of course, I'm going to cover the 3 pillars, then I'll talk about the benefits we reap. And my hope is at the end of this session, you will have some food for thought that if you like some of these ideas, you can try to see, can you leverage some of them in your own organization? So with that, let's start with some acronyms, because every engineering talk should have some of them, and I'm not an exception to the rule. So we have SDC, SCH, STF, and I was very keen on putting EP team because we call ourselves EP team, short form for engineering productivity. But with those 3, let's start. So the first one is, the pillar is automation. Inside StreamSets, we call these complex and fast evolving infrastructures as environments. So I might use these terms interchangeably. Oh, and one more logistic point, if you would try to keep your questions at the end of the session, that will be really great, because just to keep a check on time, okay? So now, these are the 4 things which I'll cover. What is the need for infrastructure automation? What was the scenario before automation in StreamSets? Our journey, meaning the phases, and a quick demo. So again, we'll go back to our familiar diagram. If you see from left to right, there are a lot of environments, a lot of different kind of infrastructures. May it be cloud like Amazon S3 or ADLS or Snowflake, or maybe on-premise your databases like Oracle, MySQL, or it might be Hadoop clusters like Cloudera or Mapr, which hosts HDFS, Kafka, Spark, whatnot, right? You get the picture. Now, for this topic or today's presentation, I want you to put yourself into the shoes of a StreamSets engineer so that we go through this journey. So this is what the customers are going to use our products for, right? So as a StreamSets engineer, your first task is develop some code and test it against these environments. Meaning, as an engineer, you need to start an environment, configure it up to your needs, and then start your actual job of development or testing against it. Now, each of the engineers has to do this task. Obviously, this itself is going to hinder the productivity, right? Because it is repetitive, it is complex, and it is going to be error prone. But of course, as the journey starts, we didn't have automation right from day one. So initially what would happen is one of the engineers will spend his or her time, efforts, and take all the pain and start up an environment in 1 or 2 dedicated machines. And then some other engineers who need to use that environment will use it. Great. As we progress, we saw there were some problems with this approach though. First of all, these are dedicated machines, meaning if they are not being used, that's a cost to the organization. Secondly, this scenario is still brittle because it is pretty easy for someone to accidentally break an environment. So this was creating problems because now again, the engineer has to go back, recreate it, the whole cycle repeats, right? So the direction was clear, automation to the rescue. Our first phase, what did engineering productivity team do? We started to create these environments for our engineers using Docker, some shell scripts, and ClusterDoc. So what is ClusterDoc? Using ClusterDoc, you can start and manage Hadoop clusters, which use Docker underneath. This is a brainchild of Dimas Spivak, who is a director of engineering at StreamSets. So this was great when we didn't have automation to this phase, right? As the time progressed, again, there were some areas for improvement. This is one example I'm giving. I imagine I want to start a CDH cluster. These are the 3 steps you have to do. Seems like, oh yeah, 3 instructions. The first one gets the code. The second one is installing the dependencies. And third one is where the actual magic happens. But the third one is the most error prone because see the number of parameters, and this is still a subset. The previous version of CDH will accept different versions of Kafka, Kudu, and whatnot. So there were high chances I'll make mistake while giving the parameters, or I might forget some of them. So obviously this was creating problems, and what we came up with is an internal tool, another acronym called STE, which is StreamSets Test Environments. What it does is, as you're seeing on the left-hand side, all those 3 lines are replaced by the right-hand side, which is a 1-liner, okay? Internally, what is happening is like this. So still, as an EP team members, we deal with the Docker, ClusterDoc scripts, all these complexities. But as a StreamSets engineer, you do not deal with any of that, and you deal with just STE. How do you do that? I'm going to show a quick demo. In fact, in this presentation, there will be 3 small quick demos. And before I start on my first one, I want to give you the usual disclaimer about demos, that demos have their own mind. They follow the Murphy's Law, and we just hope they work. So with that, let's see the first one, okay? So I am gonna be here. Can you guys see the font okay?
Yeah, looks good.
Okay. So I am interested in creating one particular environment. So I'm going to say STE start, which is pretty simple. And I'm going to say this one because that's kind of fast environment to create. Till it is starting up, I'm going to show you guys what we can do with SDE is all of these environments can be started. May it be Solar, Salesforce as a Scratch org, or there might be different kind of databases, SQL Server, Postgres, Oracle, or there might be some GCP related stuff like we create a big table instance, which is a costly using this and destroy it using SDE. Or you can create clusters like Databricks. CDH has many different variations, versions with Kerberos, without that, with SSL and whatnot, right? But you get the picture. Now let's see, this is still taking time, and the other things which we can do is, of course, there are some start, stop, restart, and some more configurations. But right now we are just interested in this one. Oh, I want to see, did it really create it? The verification is, yes, I have got it as this is my Docker container. I am gonna just verify. So right now I know it created a Docker container, but I don't know what is inside it. So of course, I'm gonna go and look inside that by a quick hash thing. And we are inside that. So let's see. The usual way to verify, oh, did I install it or no correctly? We will try to log into, yes, perfect. And our first hello world is always show databases. Great. So we have that environment. We are done with that. That's all the purpose of this. Now, as you're seeing, I still have that container. So I'm gonna use stop to stop that environment. And obviously my instruction is very simple, SDE stop. And what it is gonna do is now if I see there is no Docker container for MySQL. That finishes our first step. Very quick, easy. Let's go back to our presentation. Now let's go into the second pillar, which is the abstractions. For this, we need to look into the systems. With the increasing complexities of the systems, the only way to achieve productivity and quality is by using automation. But the automation in this context is of a different sort. We want to automate all the manual parts of system interactions. What do I mean by that, right? I'm just going to cover these three things, very similar pattern. Let's go back to our familiar pattern, the diagram, right? Remember, you're donning the hat of StreamSets engineer. By now you have done with the development of your code. Now the next piece comes is you want to test this piece for that particular environment against the StreamSets products like data collector or control hub or transformer in this diagram, right? Now the complexity is, oh, how the user is gonna use the UI to do all the user interactions. How do you test it? So right from start, our philosophy is we will manually, we will automate the paths in programmatically what the users do. What I mean by that is whatever the user is doing the interactions with the system, we will try to mimic them inside our tests and test them, right? How do we achieve that? Our answer is obviously SDK for Python. And this is another thing which we started internally. And as the Silicon Valley story goes, the customers were interested and now it is available outside also. Basically, it is a set of Python classes which use a REST API, which is already available, which talks to our various products, okay? In very simplistic terms. So we shall see another quick demo, which is gonna be again tip of the iceberg, but that shows you what it does. So for that, we are in this, and obviously the first thing which we want to do is start a data collector. I'm gonna say SDF start SDC, I'm gonna start 3.16.0, which is our latest release version. While it is starting, I'll explain what is SDF. So SDF is just an extension on top of SDK. So we have added some extra functionality like awareness of Docker, awareness of various environments and all that. And the instruction is very simple here, like it is showing SDF start SDC. Of course, it takes some extra parameters and whatnot. I'm not interested in any of them. So let's see what it is doing. So it's starting a data collector instance container because it's a Docker-based container we are starting. Yes, it's ready. It's showing me it's at port 32773. Let's see, did it really create it? And ta-da, it's ready. So this is our one of the execution engines. This is open source, and we are seeing, it's available, it's showing me. And what we are gonna do here is exactly the exercise, like I said, whatever the user is gonna do it in UI, we will try to mimic in SDK. So in the UI, I'm gonna create a pipeline. Obviously, hello world from UI. This is the canvas where literally we can drag and drop at different stages to create a data flow. I'm gonna do a very simple one. So I'm choosing a data generator. There are many different processors and all, but I'm not interested. All I'm gonna choose is a destination called trash, which is equivalent to saying send all data to /dev/null. Okay. The only other change I'm gonna do is it asks me, oh, where do you want to send if there are any error records? I could have sent it to file or other things, but I'm just gonna say, just discard them. I'm not interested. Okay? Very simple way to create it. And if I wanted to run it, I would have said start pipeline. But let's try to see, can we replicate this inside our SDK? Okay. So I'm gonna just open up a Python interpreter because ultimately it is Python code. So I'm gonna say from StreamSets SDK, import, we want to import a class called data collector. Great. Now I wish to create an instance which is talking to the server, which is available at that particular URL. What is the URL? This is where we started our SDC. So I'm gonna start it here. Great. And now I shall create an object which says, give me an instance of this particular class, which is available at the server URL. Great, up to here, that's fine. Now I can go ahead and I literally can code it, but I'm gonna do a quick shortcut. What I'm gonna do is I'm literally gonna copy code from our documentation, which is publicly available because it's available outside of StreamSets. And this is gonna do exactly similar thing and we will verify. So here we have built up the pipeline and we have given it a name called my first pipe. Let's see, did it do here? And lo and behold, our first pipeline is ready, which we created from SDK. Exactly same, dev data generated to trash. We can start it or run it using start, but we are interested to do the same thing from the SDK. So how can I do it? Very simple, because we are doing very parallel work to the UI. The method is start pipeline. So let's see, does it do here? It's showing me, let's refresh the browser. And now it's showing, yes, it is doing its job. The data is flowing through. There are output records. And I can see all the glory, record throughput, batch throughput, runtime statistics, and all of that, right? And let's do the last thing to clean it up. I want to stop the pipeline. Again, pretty simple. Okay, it's done. Let's confirm it from the UI. Yes. Now the metrics is gone. It's showing us start. Great. This is, as I said, this is just the tip of the iceberg, and you can do all the UI interactions, almost all the UI interactions inside the SDK. Like you can talk to SCH, you can talk to SDC, transformer, you can create jobs, pipelines, topologies, you name it, right? You can do it. The only thing I want to talk about is through our journey, of course, like they say, Rome was not built in a day. So we didn't arrive to this as on the first day itself when we decided on SDK, right? I remember at a particular point in that journey, we did not have this functionality of creating a pipeline through SDK. We could import, export, and everything else, but not the creation part. So what the engineers were doing were They will literally create a pipeline in the UI. Then they will go and do an export from here, which does create a pipeline of this format. And then they will import it inside the code because we had the facility to import it. Great. But the problem is, now see here, we created the pipeline in hardly 5 to 10 lines of code. The same representation in JSON is hundreds of lines of code. It's literally, I think it starts from 400, 500 lines. So this is very difficult to maintain. If you need to make single change in a configuration, which is one of the very obvious things we do, like, oh, if it was a JDBC stage, I want to change the MySQL URL and whatnot, right? To do it from the JSON is very difficult. Secondly, most of the times as we change the version from one SDC to another, there are high chances this JSON will change. There might be minute changes, but there are. So engineers were becoming frustrated that, oh, this is difficult to maintain this JSON, right? And that's what gave us the idea and motivation to introduce that functionality in SDK that we can build the pipeline, okay? That's all in the journey what we had done. So that concludes our second demo, and we go back to our presentation here. So this list of what you can do, which I talked through. Now we come to the third pillar. Now you are done with development of code. You have written some tests. They are running locally. In fact, they are running on a regular basis in CI. What is the next thing, right? The journey does not stop there. The test results which are available to us, you need to analyze and monitor them on a regular basis over time and take any corrective actions if necessary. Again, to make sure that all of our StreamSets products are of top-notch quality, right? And we use Jenkins as our CI tool, and it is really a great tool. In fact, we are still running it, and I believe we run approximately 10,000 tests nightly. As the number of tests started to increase, the engineers wanted a better way to visualize the test results. They wanted to triage the test results more effectively. And pretty soon we realized we have stretched Jenkins beyond its intended use by the sheer number of matrix cells which we're trying to triage. That tool is not intended for that, right? So obviously our solution was, we came up with an internal tool called Bifocals. In very simplistic terms, it is an Angular 9 based web app, no SQL DB in the back. Though I'm saying it in simplistic because it's very complex stuff it does internally. How does it differentiate from Jenkins? As the table shows, very simply, the first row shows we do our complete test execution inside Jenkins. Bifocals doesn't run any test. After the tests are run in Jenkins, it sends the data to Bifocals, and that's where the Bifocals springs into action. And the remaining 3 rows is what it distinguishes from Jenkins, right? So the pivoting of test results, historical and claiming, and I can talk about theory a lot, but better way is I can show you in the UI quickly. So all of those 3 rows I'm going to show in the UI. So let's see here. We are not going to go into this. So I'm going to go into our, so this is our internal product. You can see there are a lot of rows representing different products. The one which we are interested is in the data collector. And 3.17.0 is the release which is under development right now. There is a lot of data. The only thing I want you to note here is each of these builds have a Git commit ID associated with that. Why is it important? I'll talk in a few seconds later. But the point is, when this build was built, the latest commit at that point in the repo, when it picked up the code, was the associated one. That is the meaning of it. Now, let's go and look into here. So this shows us a dashboard of the tests. Total tests run were 11,285. Most of them passed. There were some failures. This pie chart is showing us all that, right? Now, um, the first point on that slide was pivoting on dimensions of the test results. What do I mean by that? It is shown here, these group by clauses, right? This functionality is hard to come by in Jenkins because we can give the dimensions what we need. Like one example is, oh yeah, I want to sort out by environments. Maybe I'm interested in only this one. This is the piece which I'm working on. Done. It's green. All I'm done, right? The other piece is sometimes you want to see by group by SDC builder. Right now, these are not upgraders. They have the same version. But many times when we run upgrade, meaning, oh yeah, you build a pipeline in 316 and then you try to execute in 317. It's same scenario when a customer is upgrading from 316 to 317, then you would have seen here multiple rows with different versions. So this is a differentiating factor. The second one is the history of tests. So like I was showing you earlier, yeah, this one was green. Now I want to see something where the tests were failing, right? Yeah, let's say I was working on Azure, something is happening, there are tests failing, green ones, I'm not worried. Let's say I want to see in this red one. I want to see, oh, what's happening? This is an error message. Fine. Now I want to see the history. When did it start to pass, fail, whatever it is, right? So I start to follow the thread. It's passing once, second time, that's it. This is my aha moment. Oh, it was passing up to here and then something happened. And this is where these are the git hashes or git commits, what I showed you on the first screen of this. And this is where it helps me. What it is telling me is, in between these two commits, something happened that caused the test to fail. So my area of searching is now pretty much narrowed down in the code base between these two commits, right? So this increases my productivity as an engineer. Great, this is a great tool because to see the same information from Jenkins runs, it is very hard. Like you have to go into each of the build and see, oh, did you run this test? Was it passing? Was it failing? You have to keep a record somewhere and all of that. This is all in one shot, right? Fantastic. Now, the last piece which I want to show here is claiming of JIRAs, which is another differentiating factor. So now if I go here, it's gonna list all of the tests. I'm not interested into the passing, so I'm gonna say the passing ones hide. And this is where it shows us. So for these tests, there is a JIRA associated with it. We have tagged it. And this is what we call the claiming of JIRA feature. And this is super helpful because it means someone has triaged through all of these tests and they have seen what is the problem and they have created a JIRA in particular projects according to it, right? This functionality is again very hard to come by when you are in Jenkins because it's not easy to combine the JIRA and Jenkins in this fashion, right? So that concludes our final demo and we go back to our presentation. Again, these are tips of icebergs, but you get the idea. Now, when we started all of this, the goal was engineering productivity. But as the time progressed, the benefits which we reaped in the process far outreach the engineering productivity. And I'm gonna mention top 3 ones here. So the first one is cost reduction. So obviously automation helps you to create environments and destroy them. It means as an engineer, now you do not have to spend time and efforts to start them, stop them, and you can concentrate on your actual stuff. You can build a test also very quickly. So this increases the engineering productivity and reduces the cost because now we are not using even dedicated machines also. The second point is the penetration of automation does not stop only at the development engineers. It helps other kind of engineers also. For example, consider a case of a support engineer. A customer reports some issue. Most likely that support engineer will have to go and create an environment to do the root cause analysis. Again, the automation helps us here. The second point is The beauty lies in the fact that these tests, once developed, they become assets for us. They automatically work towards the guaranteeing or ensuring quality for the next or future releases, right? And the third point is, as all of us know, to fix any bug which has entered production, it is super expensive. Now we have multitudes of tests. And so if we catch a bug early in the development cycle, failing fast helps our engineers to fix that bug, which is not costly. So all of these help us to do the cost reduction. The next benefit is agility. Now the abstractions and automations are in place. The engineers can focus their time and energy on their working stuff, the building of code, building of tests and whatnot, right? So that's first point. Secondly, even from our EP team's perspective, these abstractions, automations are pretty stable and extensible at this point. So we can quickly turn around any changes to them. For example, let's say you are adding some new features to SDC from 316 to 317. Now to support the same inside SDK, what we have to do is just the delta of that and not we have to start from scratch, right? So we can do it pretty quickly and easily. And so as an engineer, you get the support and you can quickly move to test that new functionality. The first and second together, they increase our release velocity. Right? And last but not the least is trust. Now, with all of these efforts, the code quality has improved, the test coverage has improved, and together they help us to build trust. To illustrate, let me give you an example. In the very early releases of the data collector, sometimes customers would face problems when they would upgrade from one version to next. And most of the times, the root cause used to be the configuration changes between these two versions. Once we came to know about the problem, we added upgrade testing support functionality inside the test framework itself, inside the SDL. So now if an upgrade test fails, we quickly know, so we quickly fix it in the code and documentation, so we catch the bugs early. Someone recently told me that after January 2018, till today, there is not a single bug reported on this after a release. Now that speaks about trust, right? Great. Now, I spoke about all these things, all this awesome work, and it is done by my amazing team, who is Dimas Spivak, is our manager, and Shred, Manjeet, and Shashi. So thank you guys for all that great hard work, right? And this is our last thing. As a summary, now you know why we did it. Because at StreamSets, we believe that automation and abstractions are necessary for engineering success. You have seen our journey, how we did it. So I would highly urge each of you, if you like the idea, when you go back to look into your own organization for any opportunity to do automation, for any opportunity to do the abstractions. When you will start, it might seem like a small step, but before you realize it, it will become a giant leap for the success. Thank you all for attending this. And now the floor is open for any questions or any comments.
Yeah, how do you decide what tasks you want to start automating?
Good question. So like I said, this was a journey, and for our case, right, the environments was a no-brainer because we have these tons of these different environments, and sometimes you think, oh yeah, creating MySQL is easy for me because I might have experience before, but maybe some other complex environment, it's not easy for me and someone has to go and spend time, right? That was first thing. So it was pretty clear. The SDK, obviously, it came into picture slowly and slowly because we believe in the quality of products or the testing. So that was another major initiative for us right from start. So obviously, so my thinking for your organization is looking into what are your needs, what are your major pain points. Like sometimes these are pain points, and that's where you go for it. Any other questions, comments?
I guess I got one for the engineering productivity team in general. So was this the plan from the beginning? Like it, because it seems like the outcome is almost like exponential because it's not just the STF, it's the test framework multiplied by the software development kit multiplied by cluster doc, and then the results of that are kind of divided by bifocals in terms of like actually organizing all of the JIRAs and stuff that fly around. Like, was that part of the master plan, or I kind of want to hear like the grander vision of how all that story came together.
Sure, I can answer that, but Dima, since you are there, do you mind to go for that? Up to you.
Sure. Yeah. I mean, it was the master plan was really that StreamSets from the beginning knew that we did not want to have a traditional QA team. The CTO of the company, the co-founder Arvind Prabhakar, he had worked at Cloudera, and he saw kind of the limits of what happens when you have a specific test engineering team that's supposed to own quality. So from the start, he knew that he did not want to be hiring testers. He did not want a test team. And so we really were just kind of coming from the standpoint of, well, if we don't have a test team, the only thing we can do is figure out ways to enable the developers. And so as time went on, a lot of that kind of came organically. So having a framework to write test cases was like day one, hey, come up with a framework that developers don't have to nerd out about, because typically developers aren't that excited about building test frameworks. They just want to be working on the product and then have kind of a low friction way of doing everything else. And then as time went on, as developers told us, hey, the framework is cool, but how do I spin up various versions of CDH with different levels of security, which is one of the things Kirti did a lot of amazing work on. It kind of organically came that way. And then over time, developers were like, I know I have this ability to do this with our stuff, but I have to read the long wiki page to actually know what series of commands I need to give it to actually start up an environment or kick off testing of an environment. And so some of these tools kind of came in response to those kind of, user asks.
Okay, cool, that makes sense. Yeah, I gotta say, just as an aside, in the field, we love using it. We use it to spin up our demo environments, and it saves us a ton of time. So we can actually get to building pipelines and telling a story.
Ah, that's great. That's great. Yes.
No, thank you for presenting. Definitely, I like that SDK.
Thank you. Thank you so much for having me here. So looks like there are no more questions. So I'll stop sharing.
Well, thank you guys. I'll be posting the video soon and let you know when the next meetup is.